Hello, this is Mike Grady, and in this video, we're going to dive a little bit deeper to understand more of what Rapsodo is telling us in the charts that it is giving us. So, uh, like before, we clicked in and saw each individual pitch and the characteristics of each pitch. However, we can click on the charts tab, and Rapsodo will show us more about each pitch and how they relate to each other when it comes to the fastball, curveball, slider, or changeup. So in the first video, we asked everyone to select the appropriate pitch type, and that would need to be done first before these charts could be interpreted correctly. So Rapsodo is showing you a grid with the movement grid with each pitch. It's also going to show the release, height and side, the velocity, tab, and then the location of each pitch. And so that is a useful tool as far as command. There's a lot more information here to interpret than what we do, even as coaches. The one chart that I do find useful is not the matrix as much as the spray chart, because this shows the movement profile of each individual pitch. And you can see that since we categorize them as curveballs and changeups, we can see that they are color coded and they're separate from one another. So let's hop over into this page to talk about how we interpret this. And so first of all, on the fastballs, the one thing we look for are fastballs to be consistent. So in this case, we see fastballs that are plotting a pretty wide range. And so we would want to see fastballs generally be pretty close to the center. So this might mean that the hand position is a little bit different on each fastball. It also might mean that maybe the pitcher is throwing a two seam that's moving a little bit differently than the four seam, which would be useful. But each fastball, if we start from the center, is telling us, if we plot down and across, how it's moving. So just a normal fastball plots about where this is. This is about 14 inches vertical. Write that in there. And then 14 inches horizontal. And that's about average for what we see for high school pitchers. And so if we want to work above average, and so if a pitcher has a fastball spin rate that's high, or we have a lot of backspin, then that fastball, maybe it plots up here at a 20-inch vertical break. And what that means is, from the hitter's point of view, the ball is falling slower than what he would expect it to on an average fastball. So because it's falling slower, the human eye interprets that ball as rising. So hitters will tell you the fastballs that tend to rise and are up in the zone, and especially are thrown hard, are hard to hit. And you're seeing in the big leagues more pitchers throwing up in the zone and throwing those high spinning four seam back spinning fastballs. So that's what that would mean if we're working on the top of that zone. Let's change colors here. If we have a fastball that's maybe over in this area where the green is, that fastball has a vertical break of 10. So compared to a four seam fastball that is rising at 20 inches, this fastball would be 10 inches off of that. So this would show a lot of sink. And because I plotted it more toward the right, this would have an extreme amount of horizontal movement. So this would have run. So I would expect that this pitch would be characteristic of a two-seam fastball that has sink and then run toward the arm side. So just interpreting this chart helps you interpret what each fastball is doing. And so in this one chart, in this one pitch, you can gather a lot of data about your fastball. If we move over to the curveball, kind of the same thing. We want to see the curveballs plot together. This is a pretty wide range. So I would suspect that the wrist position or the spin axis is changing and varying on each pitch, which is pretty common for younger pitchers who haven't really developed the consistency of that curveball. Sometimes they throw a curveball, sometimes they throw a pitch that's spinning more like a slider, and then you can see a wide range of movement here. But what we like to see is the breaking pitch plot far away from that fastball. Kind of, if you draw a horizontal line, this is where you'd expect to see a good breaking pitch, because this is moving down and away. This is a right-handed pitcher throwing, so this would be moving down and away from the right-handed hitter, and so this would be a pretty good curveball. If we had a curveball, and let me plot an example here, that was where my green circle is now, that pitch would appear pretty flat if we were watching that. It wouldn't really have a whole lot of break. And so Rapsodo would help, besides what we saw, we would see the data that would help encourage that pitcher to make a change to induce more horizontal and more vertical break in that curveball. And so hopefully this chart alone can help you interpret a little bit more about what your pitchers are doing. And so this is a big field, it's a new field. And so if you are at all interested in learning more about Rapsodo, I would definitely encourage you to see a coach that could help you interpret your arsenal. And really what we're trying to do is help pitchers create the best arsenal for them. Everybody's a little bit different. But this technology helps us determine, for example, should a pitcher throw more two seams or more four seams, or should a pitcher throw more curveballs or more sliders, or sometimes even, am I throwing a curveball or is it more of a slider based on spin? So this opens up a whole new world of interpretation, and it's a very exciting field. And I'm glad that all the pitchers in the showcase got to experience an introduction to Rapsodo and the Rapsodo data.